afternoon all. So we are going to start our today's session. This is week 10 sensor and actuator problem solving session. I am ARPITA BISWAS, a PhD scholar from IIT Jodhpur in electrical engineering department. And this is about me, that I am recently pursuing PhD in electrical engineering department from IIT Jodhpur, and I did my MTech from IIT Jabalpur in micro nanoelectronics, and I did my BTech from Maulana Abul Kalam Azad University of Technology, West Bengal in electronics and communication engineering. And this is more details about me. And the class session is every Tuesday 7 to 9 p.m. So we are starting. So here we are going to discuss about some of the question, and you can directly ask if you have any doubt. So this is the question number 1, and you can take your time and first go through the question carefully, then you can give the answer, and please unmute yourself and try to give the answer. So the question number 1 is, as you would have seen in the lecture, mammography or mammogram is technique used for the screening of breast cancer patient, and mammography uses which of the following rays? So the first option is the infrared rays, the second option is the ultrasonic wave rays, and the third option is the gamma rays, and the fourth option is the X-rays. So please go through the question carefully and then try to give the answer. I am coming back in 1 minute. So please unmute yourself and try to give the answer. Please go through the question carefully. As you would have seen in the lecture, mammography or mammogram is a technique used for the screening of breast cancer patient. Mammography uses which of the following rays? The first option is infrared rays, the second option is ultrasonic wave or rays, the third option is the gamma rays, and the fourth option is the X-rays. There is no hurry, you can take your time, but at least try. into? What type of ray is used in mammography?
No idea, ma'am.
It is X-ray. X-ray is used in the mammography. Next we are moving toward the question number 2. With respect to the piezoresistive microcantilever discussed in the lecture, to understand the mechanical properties of breast tissue, which of the following statement is not correct? So the first option is the very thin cantilever in the device was made through the silicone etching from the back side using the reactive ion etching. The second option is the mechanical stiffness of the breast tissue is measured as the resistance changes by the device through the changes in piezoresistor. And the third option is the silicone on insulator was used as the starting substrate. So go through the question carefully and then try to give the answer. And you can take your time.
Ma'am, I think first option, ma'am.
Yes, the first option is the right answer. The very thin cantilever in the device was made through the silicone etching from backside using the reactive ion etching. So it is not the correct option. So it means it is not the correct statement. So the right option is option A. Next we are moving toward the question number 3. In the piezoresistive microcantilever discussed for studying the mechanical properties of the breast cancer tissue, two types of spin on boron dopants were used to realize the device. These were boron resistor and boron contact. The following statement is true or false. So you have to find the following statement is true or false. And the statement is the resistivity of boron resistor is more than the boron contact. So it is true or false. So in the lecture video they have shown that they are using the boron contact and boron resistor both. So here the statement is the resistivity. So if you are going to discuss why they are using the boron resistor and boron contact, there the statement is given that the resistivity of boron resistor is more than boron contact or not. So the statement is true or false. You can go through the question carefully and take your time, then try to give the answer. In the piezo-resistive microcantilever discussed for studying the mechanical properties of the breast cancer tissue. Two types of spin on boron dopants were used to realize the device. These were boron resistor and boron contact. The following statement is true or false. The statement is the resistivity of a boron resistor is more than that of boron contact. So it is true or
Ma'am, I
false.
think false.
Uh, what is the answer? Is it true or false?
Your voice is not audible, ma'am.
My voice is not audible. Hello.
Ma'am, yes, ma'am. Now.
Now also my voice is not audible.
Ma'am, reason.
So what is the right answer?
False, ma'am.
No, it is true. You can see there the resistivity of a boron resistor. If you simply take a resistor, so what is resistor? At first tell me what is resistor. Banana Sindhu. What is a resistor? Normal resistor. What it does? A resistor is oppose the current flow. So when you are it's mean it is oppose the current flow. It is called the resistor. So if boron is using as a resistor, na, in that time the resistivity of this resistor is higher when this boron is used as a contact. Because what is the need of this contact? When we are using the contact, then we are taking some probes on the contact and we are taking the result. So we always want the contact resistivity always be less. So when the boron is acts as a resistor, then the resistivity of it is higher. So the statement is the resistivity of a boron resistor is more than of boron contact. So it is the true statement. Okay. Have you got Banana Sindhu?
Yes, ma'am.
Okay. Next we are moving toward the question number 4. So the question is, as you might have seen in the lecture, silicon dioxide can be formed on top of the silicon wafer in two ways: PECVD, plasma enhanced chemical vapor deposition, and thermal oxidation. So by using the thermal oxidation process like the dry oxidation or the wet oxidation, we can form the silicon dioxide, and also using the plasma enhanced chemical vapor deposition we can grow the silicon dioxide. So evaluate whether the below statement is true or false. So what is the statement now? PCVD, plasma enhanced CVD for oxide on top of silicon at much higher temperature as compared to the thermal oxidation. So what it is saying, it is the statement is the PCVD form the oxide on the top of the silicon at much higher temperature as compared to the thermal evaporation. So go through the question carefully and then try to give the answer. I am coming back in 1 minute. Go through the question. Go through the question carefully.
Ma'am, false, ma'am. Ma'am, it answer is false, ma'am.
Hello. So what is the right answer? Banana Sindhu. Am I audible? Banana Sindhu. As you might have seen in the lecture, silicon dioxide can form on the top of silicon wafer in two ways, PCBD and thermal oxidation. Evaluate whether the below statement is true or false. Physical vapor plasma enhanced CBD. Yes, it is false. Can you explain why it is false? Hello. So plasma enhanced chemical vapor deposition take higher temperature or lower temperatures. And what is the temperature need for thermal oxidation process? Banana Sindhu. Actually, in PCBD, plasma enhanced CBD, it takes lower temperature. It's operate in lower temperature. So, if we want to grow the oxide layer on the top of the silicon, it will take lower temperature than the thermal oxidation process. And thermal oxidation process, it is taking the greater than 1000 degrees centigrade. So, it is required higher temperature than plasma enhanced CBD process. So, the statement is false. Next, we are moving toward the question number 5. Penning gauge and Pirani gauge were introduced to you as part of the thermal evaporation system installation. Which of the following statements regarding them are correct? The first option is Pirani gauge is an ionization or cold cathode gauge. The second option is Pirani gauge is a thermal conductivity gauge. So the right option is only 1. And option B is only 2. Option C is both 1 and 2. Option D is neither 1 nor 2. So what is the right answer? Banana Sindhu. Please go through the question carefully. What is the right answer? Penning gauge and Pirani gauge were introduced to you as part of the thermal evaporation system installation. Which of the following statements regarding them are correct? Pirani gauge is an ionization or cold cathode gauge. The Pirani gauge, the Penning gauge is a thermal conductivity gauge. Am I audible?
Neither 1 nor 2, ma'am.
Yes, the right option is option D. Next we are moving toward the question number 6. In the process flow for the micro cantilever that was discussed in the course, the thickness of the cantilever was 2 micrometer. The overall wafer thickness was 500 micrometer. This is an extremely difficult dimension to achieve the micro fabrication. 2 micrometer cantilever using a 500 micrometer wafer. How was this achieved with good repeatability? So the first option is by dipping the wafer in BOE or BHA for exact calculation duration, or by using RIE process for an exact time duration, and option C is by using the silicon dioxide as an etch stop, and option D is by the use of silicon nitride layer. So go through the question carefully and then try to give the answer. So what is the right answer? In the process flow for the micro cantilever that was discussed in the course, the thickness of the cantilever was 2 micrometer and the overall wafer thickness was 500 micrometer. So this is an extremely difficult dimension to achieve the micro fabrication 2 microliter cantilever using a 500 micrometer wafer. So how was this achieved? With good repeatability. First option is by dipping the wafer in BOE for exact calculation duration, and second option is by using the RIE process for an exact time duration, or C is the using silicon dioxide as an etch stop, and the fourth option is by use a silicon nitride layer. Please go through the question carefully and then try to give the answer.
No idea, ma'am.
Actually, it is used by. So the right option is the option C. By using the silicon dioxide as an each stock, you can fabricate this 2 micrometer cantilever using 500 micrometer wafer. So the right option is the C, using SiO2 as an each stock. Next we are moving towards the question number 7. Evaluate whether the below statement is true or false. For the piezo-resistive micro cantilever based study of tissue mechanical properties, the fabricated cantilever was used as a custom atomic force microscope tip to study the properties in the experimental setup. So is it true or false? At first go through the statement carefully. For the piezo-resistive microcantilever based study of tissue mechanical property, the fabricated cantilever was used as a custom atomic force microscope tip to study the properties of the experimental setup. Go through the question carefully and take your time, then try to give the answer. And there is no hurry.
True, ma'am.
No, the right option is false. For the piezo-resistive micro-cantilever based study, tissue mechanical property, the fabricated cantilever was used. If you go through the video lecture, you can see the cantilever. In that case, the cantilever is AC. They have used the AC weight for the cantilever fabrication. And here it is saying the fabricated cantilever was used as a custom atomic force microscope. No, this statement is false. For custom atomic force microscope, the tip is different. And here, when we go for the measure the tissue mechanical properties, in that case they have used the AC weight tip. So the AC weight tip is used for that case. The tissue to measure the tissue mechanical property. But for the custom atomic microscope tip, the tip is different. So the right option is B option, the false. The statement is false. So next we are moving toward the question number 8. HMI was introduced as the control for the thermal or e-beam evaporation system. What does the HMI stand for? The first option is high maintenance interference, and the second option is heavy machine interface, and the third option is human machine interface, and the last option is the none of the above. So let us go through the question carefully, then try to give the answer. HMI stand for high maintenance interface, heavy machine interface, human machine interface, or none of the above.
Human machine interface, ma'am.
Yes, the right option is the human machine interface. Next we are moving toward the question number 9. Which of the below statement are incorrect for regarding the thermal evaporation system that was demonstrated? The first option is the thickness of the deposited film is monitored through a digital thickness monitor, and the second option is the inside the chamber the thickness is measured using the quartz crystal monitor. The third option is the crucible are used to hold the source in thermal evaporation while the boards are used in e-beam evaporator, and the fourth option is if not operated, the chamber has to be kept in a vacuum condition. So go to the question carefully and then try to give the answer.
No idea, ma'am.
So the right option is the third option. The crucible are used to hold the source in the thermal evaporation system while bores are used in the e-beam evaporation. Because if you go through the thermal evaporation system, then there the tungsten board and the molybdenum boards, they are used in thermal evaporation system, and crucible are used in the e-beam evaporation. So the first statement is option C. The crucible are used to hold the source in thermal evaporation while boards are used in the e-beam evaporation. Next, the question number 10 is for the interdigitate
I have doubt
electrode based on the
9 question.
hello.
No, ma'am. We can use anything in both the system, no? It is true.
But basically we are use the crucible for the e-beam evaporation system, na? And boards are mainly used to in the thermal evaporation system.
But we can use both in both the system.
But tell me, what is the need of crucible used in the e-beam evaporation? At first, tell me. If the melting
To put any
point of the source holder,
pellets of any metal. In a thermal, we use some wire kind of source. If we suppose we want to use some pellets of the metal, then we have
No,
to put
actually-
any crucible. There is a problem.
no, actually tell me why we go for the e-beam system. If the melting temperature of the the source, whatever we want to deposit, is if the melting temperature is very higher than the source or the crucible, then what we will use? In that case, we will go for the e-beam evaporation system.
Yes.
So that is explaining by this. The crucible mainly used in e-beam evaporation because it is not depends on the whatever temperature, whatever melting temperature of the source or the source holder. That's why crucible is used. So you can directly hit by the e-beam you can directly hit the source material, and it can evaporate and it is deposited on the substrate whatever you want to deposit. But in a thermal evaporation system, what is happening? They are using some boards and they are passing some current through it. So and in this case you have to maintain, you have to see the melting temperature. So if the melting temperature of the source material, whatever we want to deposit, it is very higher than the board, then what is happen? Then we are not we can't deposit this source material, because the boat will start to melt. In that case, we use the we go for the e-beam evaporation, and in that case we are using the crucible.
Okay, and crucible is not conductive, so we can't pass the current in.
Mainly, what we use, what is the need? It's the principle of the thermal evaporation system. They are using some boat and they are passing some current, and it is the heat is generated, and then the source material, it is start to evaporate, and it is deposited on the top.
Okay, the joule heating is
the
not
substrate.
possible in the crucible.
So basically we are using the crucible for e-beam evaporation system and boat for the thermal.
Okay.
Next we are moving towards the question number 10. For the interdigited electrode based electrical characterization of the breast cancer tissue that was discussed which of the following material were not used as a part of the process flow to form the device. The first option is SU8, the second option is the chromium, the third option is the silicon nitride, and the fourth option is the gold. So go through the question carefully and then try to get the answer, and there is no hurry.
Nitride, silicon nitride is not used.
Okay. Banana symbol. What is the right answer? Sindhu. What is the right answer?
Ma'am, gold, ma'am.
No, the right option is the silicon nitride. They have used the gold now for making the contact. So the right option is the option C. And the question number 11 is, with respect to the with respect to the piezoresistive microcantilever discussed in the lecture, to understand the mechanical property of the breast tissue, the following statement is true or false. SU 8 was used to form the tip of the cantilever. So is it true or false?
True, ma'am.
Yes, the right option is true. And the next question is, what do you understand by the word SOI?
Silicon on insulator.
Yes, can you explain what is silicon and insulator?
So in that is it's kind of types of vapor. The effect comes due to bulk side of the device. In the transistor, we have to remove the bulk portion. Also, they put some silicon oxide layer just below the the body of the transistor to remove the body effect and these things. So this is kind of one wafer.
And the main fabricated step, it's mean it is silicon on insulator. There is some silicon layer, then some insulator or oxide layer present, and then a thin silicon layer also present. Next, we are moving toward the question number 13. In the piezoresistive microcantilever, discuss for studying the mechanical properties of the breast cancer tissue. Two types of spin-on boron dopants were used to realize the device. These were boron resistors and boron contact. The following statement is true or false. The statement is two different boron types were used to get the good ohmic contact from the pads. So this statement is true or false. Go through the question. Go through the question carefully. I'm coming back in 1 minute. So what is the right answer? they are using in the piezoresistive microcantilever discussed for studying the mechanical property of the breast cancer tissue. Two type of spin on boron dopants were used to realize the device. These were boron resistor and boron contact. The following statement is true or false. So they have used two types of boron, the spin on boron. One of them is boron dopants and the second one is the boron resistor. So these two types of boron, two different boron types were used to get the good atomic contact. So the statement is true. Next we are moving toward the question number 14. So limitation of the thermal evaporation system.
Alloy deposition in any system.
And limitation of thermal evaporation system. Our position means
Suppose we want to put some alloy using two different metals, they have different melting points. So the concentration and all these things may not be same if we use alloy.
yes.
Or this is a challenge if the different temperatures.
And also the melting temperature different.
Yes.
And the difference between E-beam evaporation and the thermal evaporation system.
E-beam and electron beam, and then thermal we use the Joule heating.
So what is the basic difference between E-beam evaporation and thermal evaporation system? And the principle of this
The
process.
melting mechanism.
Can you explain?
Suppose we want to deposit any material, so in E-beam we use the electron beam to heating that material layer for the evaporation, and in thermal we use the current to melt and evaporate that metal. And when you already discussed in the last question that boat and crucible.
Yes. This is the question number 16. Paining gauge and Pirani gauge were introduced to you as the part of the thermal evaporation evaporator system installing. The following statement is true or false. First statement is Pirani gauge is used to measure the vacuum around 10 to the power minus 3 torr. The second is the paining gauge is used to measure the vacuum around 10 to the power minus 6 to 10 to the power 10 to the power minus 6 to 10 to the power minus 7 torr.
Both are true.
Yes, both are true. Next we are moving to which pump we have to use for high vacuum.
The diffusion and the turbo.
Yes, the turbo. Next, why chiller is used in e-beam system. What is the need of the chiller?
In sputtering, we use for that coil heating and all these things. But in e-beam, I don't know what
Same.
we have to cool down.
Yes, the same word, the chiller.
But if in thermal, the e-beam may be going same thing.
Yes. This is the question number 19. With respect to the piezoresistive microcantilever discussed in the lecture to understand mechanical properties of the breast tissue, the following statement is true or false. Actually, I think we have already discussed this, the crucible part.
Yes.
So, we are moving toward the question number 20. The working principle of e-beam and thermal evaporation. I think we already discussed this question.
Yes.
And what is the difference between the CVD and PVD? This is the basic question.
And this is also we discussed on
Can you explain again?
CVD. May we have to put some, we have to perform some reaction with gases, and PVD may there is no reaction directly. We are putting the material by knocking something.
Actually, in CVD we are putting some chemicals and gases. We are using it only the carrier gas, like argon. We are used. So when we are giving at a particular temperature, which is the melting temperature of this chemical, it is start to evaporate and it start to react. Then by carrier gas, it is moving towards the substrate and it is deposited on there. And then the next question is the type of thermal evaporation sources. What type of sources used in thermal evaporation system?
One is current we use, and EV may also count in the thermal evaporation system. No, it's different.
Actually, it is talking about the source material or source holders, I think.
But the
Source
source
holder.
material, not the supply.
It is talking
Yes,
about the source holder.
source holder, the crucible and the bottom. Yes. Source holder or source material? Types of
Source
source
holder.
material. Crucible and boat, and then some they use wire also maybe.
Actually, some boards are used, and there the tungsten board and molybdenum types of boards they are using as a source holder. And dash is the and the next question is the dash is a PVD technique in which the bulk material is released into the vacuum by bombardment from an ion sources. And this is also a very easy question.
Sputtering.
Yes. And the clean room are classified by, I think in previous session also we have discussed about it. So what is
This
clean
number
room?
of particle in per space.
Yes. And The next question is dash involves depositing successive layer of different substrate to produce layer crystalline film. So first option is atomic layer chemical vapor deposition, and the second option is combustion chemical vapor deposition. Third option is low pressure chemical vapor deposition, and the fourth option is plasma enhanced chemical vapor deposition.
I mean, layer chemical, layer by layer, I think it is
So what is the right answer?
layer chemical.
Yes, the atomic layer chemical vapor deposition.
ALD.
Yes. And in PVD, deposition occur at dash temperature.
Room temperature.
It means lower or higher temperature required for in PCVD.
Lower temperature.
Yes. And this is about the optical printing lithography process. And can you explain?
In first one we have putting that mask and that wafer in context, but they have some drawback like we can't use much that photo that mask because that is damaged by after every process. In proximity we put that mask and wafer from some distance, but there is a problem of that what we call the gap between the error come due to gap between this wafer and mask. What we call the light diffraction.
And what is the difference between the contact and projection printing lithography process?
Contact and projection.
Yes.
We put that mask and the wafer in apart from that. We put from some distance in projection, and we use some that lens to project that properly in that on that wafer to remove that error come due to that gap. And in contact we put a mask and wafer together in contact.
And what is the need of this lens in between the mask and the wafer?
To create I think smallest focusing area on the wafer.
It also decreases the feature size, I think.
Okay.
What type of oxidation process present in fabrication technique?
Wet and dry.
Yes.
Thermal oxidation.
Yes, I'm talking about the thermal oxidation. And if you want to fabricate a dielectric layer, high quality dielectric layer, which process you will follow and why?
That dry one, because there is a no byproduct come from that process, and the quality of the oxide is good compared to that wet where the hydrogen is removed.
Yes. So give an example of oxide layer which is used as a passivation layer.
Passivation layer, I think we can use the wet oxidation process.
And example of oxide which is
Silicon
used.
oxide.
Silicon oxide and also silicon nitride as a good passivation
Nitride
it is
is
used.
oxide, but it is asking about oxide.
Yes. So I think for first 9 to 10 question you are not there here, na? So we can discuss
Yes.
this question.
Ah,
So this is the first question, as you would have seen in lecture. Mammography or mammogram is a technique used for the screening of breast cancer patients. So mammography use which of the following rays? So first option is the infrared rays, second option is the ultrasonic wave rays, third option is the gamma rays, and fourth option is the X-rays.
X-rays.
Yes. This is the second question. With respect to the piezoresistive microcantilever discussed in the lecture, to understand the mechanical property of breast tissue, which of the following statement is not correct? The first option is the very thin cantilever in the device was made through the silicon etching from backside using the reactive ion etching. And the second option is the mechanical stiffness of the breast tissue is measured as resistance changes by the device through the changes in the piezoresistor. And the third option is silicon on insulator was used as the starting substrate. So go through the question carefully and try to give the answer.
I think we use silicon as a substrate, not the silicon on insulator. Maybe this is.
We also can take silicon on insulator. Whatever the device they have prepared in the lecture video,
So
they
they
have
can put on the silicon, the SI wafer also.
they have make the device on silicon and insulator.
This is right, then second is also right. The first one is wrong.
Yes, the
They
first one
use
is wrong. The very
so they use
thin,
chemical etching process for that. No reactive
the
ion
very
etching.
thin cantilever in the device was made through the silicon etching from the backside using the reactive ion etching. From the backside, where can use the wet chemical etching, na?
Hmm.
Then the question number 3 is, in the piezoresistive microcantilever discussed for studying the mechanical properties of the breast cancer tissue, two types of spin-on boron dopants were used to realize the device. These were boron resistor and boron contact. The following statement is true or false. The resistivity of boron resistor is more than that of boron contact. So is this statement true or false?
True.
Yes, it is true. The next question is, as you might have seen in the lecture, silicon dioxide can form on the top of silicon wafer in two ways, PCVD and thermal oxidation. Evaluate whether the below statement is true or false. PCVD form oxide on the top of silicon at much higher temperature as compared to thermal oxidation. So is this true or false?
EVCUD is a low temperature process, so it's a false.
Yes, this is false. Next question is, Penning gauge and Pilani gauge were introduced to you as part of the thermal evaporator system installation. Which of the following statements regarding them are correct? The first statement is Pilani gauge is an ionization or cold cathode gauge. The second statement is Penning gauge is a thermal conductivity gauge. So the right option is only one or only two or both 1 and 2 and or neither or not 2.
I have read this but not remember right now. Someone is use thermal conductivity process to measure that pressure in that. Maybe That is Pirani, I think, used for that. I don't remember right now.
Actually, both are used for measuring the pressure, I think.
Low
So,
vacuum, yeah. But
yes.
the principle they have written here, ionization or cold cathode gaze.
So the both option is wrong. The statement is wrong. So the right option is option D. Neither no on or not to. Okay.
Mhm. I think Pirani gaze is used for thermal conductive process, maybe. Also.
And the next question is, in the process flow for the micro cantilever that was discussed in the course, the thickness of the cantilever was 2 micrometer. The overall wafer thickness was 500 micrometer. So this is an extremely difficult dimension to achieve in microfabrication. So 2 micrometer cantilever using the 500 micrometer wafer. How was this achieved with good repeatability? So first option is by dipping the wafer in BOE or BHF for exact calculated duration, or by using the RIE process for an exact time duration, and the third option is by using the silicon dioxide as an each stop, and the fourth option is D, uh, by the use of silicon nitride layer. So go through the question carefully. I am coming back in a minute. So what is the right answer?
See,
Yes, the right option is C. By using the silicon dioxide as an etch stone. This is question number 7. Evaluate whether the below statement is true or false. For piezo, for the piezoresistive microcantilever based study of the tissue mechanical properties, the fabricated cantilever was used as a custom atomic force microscope tip to study the properties in the experimental setup. So is it true or false?
true.
No, this is false. If you go through the lecture, you can see there they have used the SO8 as a tip for the fabricated devices. And here the statement is the fabricated cantilever was used as a custom atomic force microscope tip. No, they have used the AC weight tip and they fabricated their devices. So the right option is B, false. And the next question is HMI was introduced as the control for the thermal or e-beam evaporation system. What does HMI stand for? The
The
first
human machine interface.
yes, human machine interface. And the next question is which of the below statement are incorrect for I think you have gone through this question.
Yeah, I attended this.
Yes, so this lecture is ended here, so you can leave. And if
So
you have
Arpita
any,
ma'am, I asked earlier also, do you have these question bank of kind of thing in a document file?
yes, I
Because
will, at the
copying
last I will upload it. Okay,
you uploaded.
I will upload.
Okay. Okay, thank you.
Okay. So here in this question, what is discussed? This question I am going to discuss for those students who are not joining this lecture, but who can get the idea or discussion about this type of question, how to solve. So the below statement are incorrect regarding the thermal evaporator system that was demonstrated. The thickness of the deposited film is monitored through a digital thickness monitor. The second option is inside the chamber, the thickness is measured using the cross crystal monitor. And the third option is the crucibles are used to hold the source in the thermal evaporation, while the boards are used in e-beam evaporator. And the last option is if not operated, the chamber has to be kept in vacuum condition. So in thermal evaporation system, at first the fourth we are going from the last option. If it is not used now, so then we have to put the system, kept the system in vacuum. Otherwise the particle from outside it can go inside and it can create the contamination. So the last option is the right option. And the second option is inside the chamber the thickness is measured using a cross crystal monitor. So inside the thermal evaporation system there is a monitor present which is cross crystal monitor. So it is also it is also the right option. And the first option, the thickness of the deposited film is monitored through the digital thickness monitor. So it is also the right option. So what is saying about the third option, the crucible are used to hold the source in the thermal evaporation, while boards are used in e-beam evaporation. So boards normally used in thermal evaporation system, normally tungsten, molybdenum and the tantalum boards are used in e-beam evaporation system. And for the e-beam the boards are used for thermal evaporation system and e-beam evaporation system. The crucible are used which is because in e-beam evaporation directly electron beam can go the source material which we want to deposit, and then it is heated up and it is start to evaporate and it is deposited wherever we want to deposit that material. And there is no need to no need of any conducting source holder or source material, source holder. So that's why the crucible is used for the e-beam evaporation. So the third option is not true. So the third statement is not true. So the right option is third. That's option C. So the next question, option 10, is for the interdigited electrode based on the electrical characterization of the breast cancer tissue that was discussed. Which of the following materials were not used as a part of the process flow to form the device? So the first option is acetate, the second option is chromium, the third option is the silicon nitride, and the fourth option is gold. So what is the right answer. Go through the question carefully and then try to give the answer. So here we are discussing about the some of the optical lithography, printing lithography process. The first figure you can see, we can discuss about some optical printing lithography process. First one is the contact lithography, second one is the proximity, and third one is the projection. So here the light source is present, and then a condenser lens is present, which is where the light is passing through this condenser lens. Then there is a mask, and in contact printing photolithography process, the mask is directly connected to the device. Here is the silicon wafer is present, and then the photoresist. So what happened in photolithography process, the pattern is transformed from the mask to the underlying layer. So the photolithography process, the pattern is transformed from the mask to this photoresist layer. Then after the process, like the development, after exposure, then development, this and etching, this pattern is transferred from the mask, the photoresist layer, to that silicon oxide or silicon dioxide or the wafer. Okay. So what is happened for the contact printing lithography process, the mask and for the wafer which is in direct contact. So there is a, if it is applied for a long time, there is a possibility of the defect present in that wafer. So to overcome this this limitation, we can use the proximity printing lithography process. What happened in proximity printing lithography process? The same process is here. This is a light source, then the condenser lens is present, then the light is passing through the condenser lens and it is going to the mask layer, and there is a small gap between the mask and the wafer. You can see here directly there is a small gap between the mask and the wafer. So it can reduces the defect, the type of defects present whenever the mask, whatever the limitation is there, na contact printing photolithography, there is a contact between the mask and the wafer, so it can damage the wafer. So if there is a small gap between the mask and the wafer, so it can reduces the defects. And next one is the projection. So in proximity photolithography printing photolithography process, there is also some limitation, like the feature size. If you want to reduces the feature size, na, in that case we can go for the projection printing lithography process. So what happened in this projection printing lithography process, there is a light source which is passing through the condenser lens, then it is going to the mask. Then the in between the mask and the wafer, there is a lens present, the objective lens. And what is the need of this objective lens? It reduces the feature size. The pattern is transferring, so the pattern transferring from the mask to the underlying layer, so it reduces the size. That's why the projection printing lithography process is used. So this is the three types of printing lithography technique: contact printing, proximity technique, and the projection printing lithography process. And this is the oxidation process. Now we are discussing about the oxidation process. So there is a two type of oxidation processes present, like the thermal oxidation process, the dry oxidation and the wet oxidation. What happened in dry oxidation? It required more temperature, like 1200 degrees centigrade, and also the oxygen is passing through, the oxygen is passing into the chamber, and this oxygen at higher temperature it react with the silicon, and it also grow the silicon dioxide on the silicon. And what happened in dry oxidation, the water vapor is also passing also in the chamber, and also with the presence of the oxygen, and oxygen and water vapor both react with the silicon, and it's grow the silicon dioxide. But the and also the time required for the dry oxidation is larger than the time required for the wet oxidation. It is very faster process, and but there is some limitation or the problem, because it's in wet oxidation, because in wet oxidation the byproduct hydrogen is present. That's why the quality of the silicon dioxide not that much good. So you can use this type of silicon dioxide as a passivation layer or some other the isolation layer. But if you want to prepare some good oxide layer, like if you want to use in dielectric layer or something else, in that case you can use the dry oxidation process, and there is no byproduct. And what is the main difference between the CVD and the PVD? The CVD full form is the chemical vapor deposition, and the full form of the PVD is the physical vapor deposition. So in chemical vapor deposition, some chemicals are used, and they and also some carrier gas is flowing through the chamber or the tube, and and we have to give some temperature which is equal or some greater temperature of the melting point of the source chemical or the source material. And when it start to evaporate, and then it reacts, and by using the carrier gas, it is start to deposit on the on the wafer or the substrate. And what is the PVD technique? Physically, like when we are passing in for the thermal evaporation or e-beam or sputtering system. In sputtering system, all of you know that you are following, you have to maintain the chamber atmosphere, and also you have to flow the argon, and its argon directly hit the heated the target material, and it is bombard onto the target material, and then it start to deposit on wherever we want to deposit this target material. Okay. And what happened for the thermal evaporation? We have to keep the source material in the source holder, and the melting temperature of the source material is lower than the melting temperature of the source holder, and then you have to pass the current through this source holder, and the source material is start to evaporate, and then it is going evaporate, and then it deposited on the material on the substrate. And what happened for e-beam evaporation? There is if the melting temperature, and there is no, if there is a melting temperature issue, then in that case you go for the e-beam evaporation. And here you can use the crucible, the source holder, and also you can directly e-beam you can use the e-beam if e-beam is heated or targeted on the source material, then it will start to evaporate, and then it deposited on the source material. So now we are ending this session. I think we will meet again on Tuesday, next Tuesday, 7 to 9 p.m.